at all. But pretty much the only ones we haven't talked about at all would be this year 2 and 12. 2 you may or may not, maybe should know from a previous year, maybe not. All the rest we either talked about this year, like, so it's going to be more of like review and reestablishing it in a different way, but things that we did do this year already, or should be stuff that you did other years. All right, so the first part of this is going to be properties of exponents. So for any real numbers x and y and integers a and b, the product of powers is if you have the same base for both, then you add the powers. Right, so this would be like the examples here. If you had 3 squared times 3 to the 4th, that is the same as 3 to the 2nd plus 4, right? Which is 3 to the 6th. The same works for a base value for like p or something like that. Quotient of powers is the same kind of thing, but with subtraction. So if you have x raised to a power over x raised to a different power, it is the subtraction of the 2 powers. So if you have 9 to the 5th over 9 to the 2nd, that's 9 to the 5 minus 2, or 9 to the 3rd. Negative exponents just move something to the denominator. So a to the negative, x to the negative a is 1 over x to the a, or 3 to the negative 5th is 1 over 3 to the 5th. So it doesn't do anything with a negative there. It doesn't make the term negative. In the exponent, it's talking about whether it's in the numerator or denominator. Power of powers, this is where you multiply. So if you have a raised to the b power, then you are raising it, multiplying it by. Powers of a product, you just distribute that power as long as the inside is just a product. Remember, we do something different if there's addition, which we did in previous chapters, right, where you have to FOIL or distribute and stuff like that. But if it's just multiplication, then you just distribute. The same is true for the power of a quotient. And then the last one there is the 0 power. This one you should remember from, I believe, Algebra 1 or pre-algebra, which most of this stuff should have come up in pre-algebra as well. Power just says anything raised to the 0 power is 1. So 9 to the 0 power is 1. 12 to the 0 power is 1. Product of powers, let's just take a look at some of these and show that they make sense, right? So a product of powers, that's the one that says if we have 3 to the 2nd times 3 to the 4th, actually this might be the exact one they used, which is fine, we get 3 to the 6th, right? So why does this make sense? Well, it makes sense because 3 squared is what? It's 9. It's also 3 times 3, right? 3 times 3 is 3 squared, right? The squaring, the exponent is just a simplification of multiplication, like a redundant or overused multiplication. And 3 to the 4th is what? 3 times 3 times 3 times 3. So here, right, we have 3 times itself how many times? 6, right? There are 6 3s. That's all that this property is telling us, right? Is that this would break up that way. The same would be true if we used anything else, like x to the 4th times x to the 7th. The x to the 4th is just x times x times x times x. The x to the 7th is x times itself 7 times. So how many times are you multiplying x by itself? 11, right? So we're just adding the 4 and the 7. Quotient of powers would work kind of the same, just obviously in reverse here, though I would probably use it as a negative exponent and then do product of powers, where like if you have like 3 to the 5th over 3 squared, right? The 3 squared is actually a 3 to the negative 2nd, right? The negative exponent allows us to move it up and become a negative power. And then it's just addition. 3, wrong number. 3 to the 5 plus a negative 2 would give us 3 to the 3rd. Again, 5 minus 2 is that 3rd. This also makes sense, right? I can show it one other way that might fit a little bit better. What is 3 to the 5th? Over 3 squared. What would we do, right? It's all multiplication, so it's just, use a different color. It's just canceling out, right? So I am subtracting the 2 from the denominator from the numerator, and I'm left with 3 3s. That is 3 cubed, right? So that's what's happening with this. Again, this is all just trying to make it so like it's not just a property, it does make sense, right, with other things that we would know. 3 squared to the 3rd power, right? What does this do first? The 3rd power says that this is 3 squared times 3 squared times 3 squared, right? So this is recognizing what the exponents actually do. Since it's cubing this, it's just taking this term times itself 3 times. So we have 3 squared times 3 squared times 3 squared. That is 3 times 3 times 3 times 3 times 3 times 3. How many 3's are we multiplying together? 6. And that's how we get that 2 times 3 happening, right? Power of a product will work kind of the same way. There's some rearranging done in there, but that one's usually fairly easy to remember. Power of a quotient, except for the negative one, we have used before when dealing with fractions. Like if we had 1/2 squared, we have said before, I don't remember this class or last year for sure, that that's 1 over 4 because it's 1 squared over 2 squared, right? So that's just a distributive type thing, just like the multiplication. All right. While we're simplifying monomials, a monomial expression is simplified when there are no power of powers. Each base appears exactly 1 time. All fractions are in simplest form, and we don't have any negative exponents.
To the 14th, my bad.
Yeah, C.
I was thinking 14th then correct.
C to the 14th, right? This is C to the 12 minus 4 plus 6. 12 minus 4 is 8, plus 6 is 14, so we get C to the 14th. All right. This one is B to the 6th, because we have B to the 8th, the numerator's exponent, minus the denominator. So b to the 8 minus 2, which gives us b to the 6th. A to the 4th to the 5th, right? This means that we're taking a to the 4th times itself 5 times, right? Every a to the 4th is a times itself 4 times, and we're doing that 5 times, so we get a to the 20th. Again, you can also look at that as a to the 4 times 5. Again, a to the 20th. All right, so as we're working on these ones, there are different ways to kind of think about this. One would be to kind of just do it, which is typically how I'm going to. The others would be to move it and then add or subtract as necessary. Those would probably be the two. So I look at it and say x to the negative second. Since I have an exponent of a negative that has to move to the denominator, when I move it to the bottom, it is no longer x to the negative second, right? It becomes positive. So I have x to the second and x to the 4th. And that gives me x to the 6th, right? So the x to the negative second moves to the denominator. That gets rid of the negative. The negative is what moves it. So then it's positive. Then you're just adding the exponents. So then we need to look at the y values. Right? So it's y over y to the negative first. So if we're bringing it up, we have y times y, right? Y times y is y squared. Y times y is y times itself. There's two y's. Correct. So yeah, the negative just moves it to top or bottom is typically how I look at it. Again, you have other choices. You can do it specifically that way and write it out. You could also follow the rule very, very specifically, which says what we should do is take x to the, let's do a different color. What we should do is take x to the negative second and subtract 4, right? And then we should take y, which is to the first, minus a negative 1, right? This is what the rule actually tells us to do. X to negative 2 minus 4 is negative 6 times y to the 1 minus a negative 1 is 2. Now this can't be simplified because we have a negative exponent, so we would move it to the denominator, which would give us y squared over x to the 6th, right? The same thing that we got before. You can look at it either way. You can like either one. Like I mentioned, you can kind of spread this one out a little bit more as well, which would be to say that this is, well, if I move that exponent down, I get y, and I'm moving the y up. So I get y times y over x to the 4th times x squared, and then it's just adding exponents there, right? So it is your choice on whichever one you like better. I said I like that way better. This is what the rule specifically says, though you can use rules to kind of do it that way as well. Number 5, we're raising the whole thing to a negative first power. So again, we do have options here. One of them is to distribute the negative 1 to each part individually. However, looking at it, the only thing that'll really help us with is the a to the negative third. Everything else gets mixed up then. A to the negative third. Otherwise, the negative first power is just giving us a reciprocal, right? So the first thing I would do here is just to rewrite this as a to the negative third b squared over a squared b. So since it's raised to a negative first power, it's just flipping the numerator and denominator. Now there's only one thing that we need to move, right? We have an a to the negative third, that's no good. So what is a to the negative third? It's the same as putting an a to the third in the denominator. So I have a squared times a to the third, which is a to the fifth. You add exponents or subtract exponents, depending on which way we're looking at it. And then we have b squared over b, which is just a b left in the denominator. Sorry, in the numerator. So we have b over a to the fifth. Because it's b squared, that's positive. It's not a negative exponent on the b. Again, for number 6, we have options. So the two options we have here is we can either distribute the square in first, or we can simplify the inside first. And typically, I'm going to distribute the square, or at least I think I would. So when I do that, it's to square each of the things on the inside. So I get x to the fourth, y squared all over y to the sixth. Good. It's x or y to the third squared, which means we multiply exponents because they're being raised to power. We have x to the fourth over x squared, right? That's 4x's over 2x's. So if we cancel the 2 in the denominator, we're left with 2 in the numerator. So we have x squared over, we have 6 y's in the denominator, canceling the 2 y's in the numerator. How many do we have left? Number 8 should have been pretty easy, right? M to the 15th, right? It's multiplication of the same base, so we just add exponent. 7 plus 8 is 15. Number 9, we have 8 over 4, which is 8 over 4 is 2, right? We have m cubed over m, so we have m squared over, you can look at each part separately. So we have numbers 8 over 4 times m cubed over m times n squared over n cubed, right? So 8 over 4 is 2, m cubed over m, that's m cubed minus the 1 in the numerator, right? And then you have n squared over n cubed. So that'd be n2 minus 3 is negative 1. So n to the negative first is just an n in the denominator. Or again, you can look at it as canceling. So you have 2 over 3, right? If you have 2 of something over 3 of something, they cancel, and leaving you with 1 in the denominator, none in the top. All right, let's take a look at our first one here. So we have 1/2. We're going to distribute the square. Negative 5 squared is 25, right? Negative 5 times negative 5 is 25. A squared squared is a to the 4th, and b cubed squared is b to the 6th times a squared, b squared, c squared.
So wouldn't it just be adding so it'd be a to the 6, b to the 8.
A to the 6th, right? A to the 4th plus a to, or times a to the 2nd is a to the 6th. B to the 8th, c squared. What do we do with our numbers?
Put the number to in front of the a.
So we want 25
Now we're gonna time it.
all over 2. All right, quickly here, t squared over t squared is something over itself is always 1, right? So that basically cancels itself out. Not basically, it does. So if that's what you meant, it canceled itself out at 0. I think that's probably what you meant, so you're not wrong. You just kind of said it the wrong way. C to the 4th over c to the 4th is, right? This is c to the 4th minus that 4, right? 4 minus 4, so we get c to the 0. That might also have been what you were talking about. C to the 0 is 1, so it's gone. 2 to the 3rd over 2 squared leaves us with 2 to the 1st, which is just 2.